In this video, we're going to be looking at the grade 10 theory chapter 3, Basic Concepts of Hardware, and this is from the DBE textbook. Let's start with some background and some comparison to put things into perspective. Back in 1969, when the first moon landing occurred, they used 5 of the state-of-the-art computers, for back then of course. These computers had 1 megabyte of memory and were on average the size of a fridge. So very big, very small amount of memory. To put that into comparison for you, today we buy a RAM stick memory smaller than a chocolate bar, which contains on average, for an average person, 8,000 megabytes. And what do we do with all of that spare RAM? We play Candy Crush or something like that. Anyways, to go on further, there is a very famous computer scientist from that era called Gordon Moore, and he formulated a prediction which later became known as Moore's Law. You should know about this. It's good general knowledge for somebody in the IT field. And it basically states that every 2 years, the power of computers, the grunt that computers have, the speed, will double. So it was just a prediction, but it turned out to be pretty accurate. Every 2 years, the average computer power doubles. Throughout this chapter, we're going to be looking at the following parts of hardware. So input, output, memory, which is RAM, storage, processing, which is your CPU, and communication. Starting with input devices, hopefully you remember what an input device is. It's any device, remember we're talking about hardware now, which you can use to input instructions or information into the computer. And that's why it's called input, because it's something that's coming from the outside into the computer system. And here we have examples of typical input devices. Ones that we know well: keyboard, a mouse, touchscreen, touchpad, cameras, game controllers from a PS5 or an Xbox, microphones like I'm using now to record this video, scanners which scan a document which is on a piece of paper and scan it into a digital form onto a computer, and so on and so forth. Let's have a look at some of these in a bit more detail. We'll start with a keyboard because we're all familiar with a keyboard. Let's look at an advantage and a disadvantage. So most computers come with keyboards built in, and so because of that, everybody who has used the computer for a period of time is familiar with the layout. In fact, it has a name. It's called a QWERTY layout on the keyboard, and we call it that because if you look from the Q letter to the right, it spells out the word QWERTY just because of how the layout is, and so that's what we call it. When it comes to inputting text, words, into a computer, the keyboard is one of the fastest ways that we can do it, so that's one of the advantages. The disadvantage, however, is that when it comes to modern computing, like what we have today, where we have a graphical user interface, GUI, with icons, apps and things like that, pictures to click on, a keyboard doesn't do very well. It can be done. You can select different icons using the arrow keys, press enter to start a program, but it's slow and it's not intuitive like a mouse, for instance. So moving on to a mouse, another one that we're very familiar with, let's look at one of the advantages over there. Most computer users are familiar with them, and you don't need special training in order to use a mouse. It's very simple and straightforward. The disadvantage of this is, of course, you can't type text with a mouse. Even if you had all of the letters on the keyboard going individually to select each key would take much longer than using a keyboard. Also, a mouse needs space and a specific type of surface in order to work correctly. If you are on the move with a laptop, you might not have a flat surface that you can use a mouse on, so that's a disadvantage. All right, the next one is a touchscreen. The only thing I'm going to mention here is that a touchscreen falls under input and output, because a touchscreen, when you touch it, it acts as a mouse. You are inputting an instruction via clicking on something, or with your finger you're tapping on something. So that's input. However, because it is a screen, it is displaying information that's coming from the computer out of the computer to your eyes. So that's output. So a touchscreen is one of those unique devices that qualify or fit under the category of input and output. All right. The rest of the input devices are self-explanatory. You just need to read through it yourself. There's no need for me to make special mention of it. Let's move then to output devices. So under output devices, we have displays like a screen, printers, which take data from the computer and print it on a page or something like that, a data projector, and speakers to output sound. Let's start with display devices. So monitors. This can be a monitor built into a laptop, a separate monitor for a computer, or even a TV screen. Monitors are interesting because there's a couple of specifications which we need to be familiar with. The first is the resolution, or the number of pixels. When it comes to screens, if you look really close, if you put your face really close to the screen, you might be able to identify individual pixels. This was easier a few years ago when they weren't so densely packed. It might be a bit difficult, if not impossible now, but there are individual pixels which make up the screen. Each pixel represents one color. So if you're looking at a detailed picture of somebody's face or a view of the horizon, for instance, with many different colors and lots of detail, each pixel can only display one color at a time. So the more pixels you have, the more detail you have. If our entire screen was one pixel, it would literally only show one color at a time, and you will not be able to discern anything from that. So modern day screens, like the standard now, is full HD, high definition, which is a combination of 1920 pixels going from left to right and 1080 pixels going from top to bottom in one row. If you multiply those two numbers together, you'll get a big number. That is the total amount of pixels in the screen. So yes, a lot. You can see over there at the bottom they mention 4K. Perhaps you've heard of that. It's quite a buzzword these days. TVs are coming out with 4K resolution. If you look at the number of pixels there, it's 3840 from left to right and 2160 from top to bottom. So they're using the left to right standard 3840 and they're just rounding it up to 4000, hence 4K. Next is the screen size, the size of a monitor. We measure this diagonally from from the one corner of the screen to the other corner, from top to bottom, kind of, right? So diagonally. We also mention, or we measure this in inches. That seems to be the international standard. Next, after that, is the refresh rate. This is how quickly or how often the monitor or TV can display a new image. So the default for most decent monitors and TVs is 60 hertz or 60 hertz for a for a refresh rate. So that means it can update or change the picture that's on the screen 60 times in a second. In order to get a moving picture, a video simply consists of a lot of still images moving quickly from one to the other, and your brain processes that as a moving video. for our eyes, a average refresh rate of about 23 to 24 will look like a roughly smooth video. Anything less than that, so let's say 15 frames per second, you will be able to tell that this is quite choppy. And less than that, maybe 10 frames per second, you can easily tell, wait, this is still images, just 10 of them every second, but it's not going to look very smooth. So most monitors and TVs are set to 60 so that it appears nice and smooth, and you're not going to get any jittery or things like that. The contrast ratio is a measure of the number of shades a monitor can show between the darkest and blackest black color to the brightest white color. So the further or the bigger the contrast ratio, means the further that these two values are from each other, means that there can be more individual different colors in between. So you want a high contrast ratio for the best contrast. Second last over here is the aspect ratio. And this doesn't really have to do with the size of the screen, but more of the shape of the screen. Back in the day, when we had box TVs that looked more like a square, that had an aspect ratio of 4:3. So almost a square, but not quite. Today, most monitors are either 16:9 or 16:10. So again, they measure, or they give as an example here, the size of the screen, but in reality it's a ratio. It has nothing to do with the size of the screen. It could be a gigantic screen like at the movie theater, which could be 16:9, or the monitors that we use in class, or the laptop I'm recording this video on. Small screen, but it still has an aspect ratio of 16:9 or 10. So it's more of like a rectangle. And the last one here we have is the brightness. The brighter your screen can go, the better it will be for viewing in bright environments when the sun is shining through the window. Next up, printers, the next output device. So what do printers do? They take a digital page or digital format and they print it into something tangible on a piece of paper, a cardboard, or something to that effect. There are 3 types of printers that they mention here. You can read through all of them, but I'll quickly mention the important ones. First of all, dot matrix printers are old, and you hardly ever see them anymore. You can YouTube a dot matrix printer to see what it looks like. One of its most, what can I say, infamous telltale signs is that it makes a lot of noise. What you find today is either an inkjet printer or a laser printer. So both of them are used, modern printers. However, they have different use cases. So in offices, you're most likely to find a laser printer. Laser printers are very good for printing documents. They print extremely fast. They don't use a lot of consumables. They don't use ink. They use toner, which is slightly different. But they don't use as much as an inkjet, for instance. Also, how you can tell that a printer is a laser printer, when the paper comes out, it always feels warm because it's necessary for the electrostatic technology to work correctly. Inkjet printers, on the other hand, the jet part is quite literal. It sprays the ink onto the paper. Inkjet printers are used because when it comes to color and detail in pictures, an inkjet printer, or a good quality one, will print much better, clearer, high definition images compared to a laser printer. However, it uses a lot more ink. Even if you're printing the same stuff, it just uses more ink. That's how it is. A 3D printer uses plastic or something else. It doesn't have to be plastic. And it prints objects one layer at a time. So it's very much a layer process. Starts with the bottom layer, works its way up until you have your item. Now, a piece of paper or an object also has a resolution, a quality of how fine and how detailed it is. However, because a piece of paper, for instance, doesn't have pixels. Remember, a pixel is something that a screen or monitor has. A piece of paper doesn't have pixels. It doesn't have little lights showing colors on it, obviously. So how do we measure the resolution? We can't use the amount of pixels on a piece of paper, and so we use DPI, dots per inch. Measures how many dots a printer can print in 1 inch of space, 1 inch squared, which is about 2.5 centimeters squared. So if a printer can print 300 individual dots without printing on top of the other one in that small amount of space, that's considered an acceptable resolution, a decent one. All right, and then pages per minute, ppm, as it sounds, measures how many pages the printer can print per second. Obviously, this is not pictures. Pictures will obviously take longer. This is normal documents. And the winner there will always be a laser printer. Data projectors. I think we all know what one of those are. We have one in class. The main purpose is to project a small screen like my laptop onto a big surface so that many people can view it at once. Now there's two types of cable technology that we use or we can use to connect to a data projector. The older method, but still probably the most popular, is the VGA connection, an analog video only connection. So it can only transfer images, and you can see what those look like. If you look at the side of a laptop or at the back of a computer, it's usually a blue or black port, but you can just give it a Google and then they'll pop up. The reason why they're still so popular is because they get the job done. Essentially, they get the job done, they're good enough. There is newer technology like the HDMI, which we're going to come to in a second, but the VGA is still capable enough. Many laptops have it. Even if your laptop is 10 years old, you'll still have a VGA connection on it. You probably won't have HDMI if it's that old, but you will have VGA, and so you can use it. So they're keeping it around for legacy purposes. Right, so the newer alternative is HDMI. And HDMI does not just allow high quality video and images, it also allows audio through the same cable. If you wanted to get audio via VGA, you would have to use a separate cable because VGA does not carry audio, but HDMI carries both. All right, so we're still talking about projectors. Let's have a look at some of the disadvantages. So we know what the advantages are. You can move them around because they are portable unless you fix them in place. And you can project a small screen onto a large area so that many people can view. However, replacing parts like the lamps inside, it must have a very strong lamp to project the light. They are expensive. Low quality projectors can be washed out or faded and very pixelated, meaning that there's not a lot of pixels to make up the quality. Low brightness projectors will struggle if you're not in a dark room. And usually if you find you want to buy a cheaper one, you'll struggle with low quality, low brightness, and things like that. So when it comes to the brightness, we measure this in lumens. That's the measure of the brightness of a projector. The resolution, as you know, is the number of pixels. Remember, a projector is just projecting the image of a computer screen. So we use pixels to make up the resolution, and it also has a contrast ratio. The higher the ratio, the better. Speakers and headphones. Right, so we're familiar with that. The advantages there are um, that we can listen to music or audio of any kind without disturbing people around us. They take some time to make special mention about input and output devices. So earlier, I mentioned that a touchscreen falls under both input and output. Another option here is an interactive whiteboard, where you use a projector, which is output, to display a screen on the whiteboard, but it is synced up on a touch screen surface that when you click wherever you like to click, it controls the computer as you were using a touchscreen. So input and output. Storage devices. So storage devices are there to store your programs, your documents, your files when the computer is off, for long-term storage, when you don't have electricity, so that either the lights go out or you're moving your computer from place to place, your battery dies. Basically, storage, remember that word, ensures that your stuff is permanently stored for when you need it later. Now, there are a number of storage devices. Some of the most popular ones are hard drives, which you usually find in a computer or a portable hard drive. There's also a flash drive or a flash stick. CDs and DVDs are also storage. They permanently store. Even if you go further back to when we used tapes, that was also permanent storage. And there are a couple of other ones as well. When evaluating any storage device, there are certain things that you must take into consideration. The function, that determines whether you need an SSD or a hard drive. Storage capacity, so how much you can store on it, determines how much information you can store. So a hard drive would probably be best in that regard, and a flash drive would be less, and a CD would be obviously right at the bottom there with the smallest amount of space. Portability. Hard drives that usually plug into a computer are not very portable. However, a portable hard drive, which is cased specifically for that purpose, or even better, a flash stick, is the most portable. Use, that determines what the storage device will most likely be used for. This includes transferring files and running applications. Volatility determines if the device will lose the data when it is turned off. Obviously, we don't want that. Reliability and durability. This determines how likely the device is to break down. Now, a hard drive is great, but not very durable. It has moving parts inside of it, so if you happen to drop it and those moving devices make connection with each other, you can instantly lose all your data. And so something like an SSD, which has no moving parts, or a flash drive, is better when it comes to durability. All right, let's start with the hard drive, or the HDD. A computer hard drive is a secondary storage device. Secondary storage means that it is permanent storage. Your stuff is not going to be lost if your computer goes off. All right, it consists of magnetic disks. So it literally has disks, not CDs. They look like CDs, but they're different. Disks that rotate at high speed. And it has a read and write arm, which interacts with the disks to pull information or add information to the disks. So we have moving parts, and therefore this is classified as a mechanical device because the disks and the read-write arms move. So we do have hard drives which can be portable. You can see there on the image on the right-hand side. They are specifically packaged though within special packaging with special cables and stuff to be portable. But again, they still have moving parts, and so if you drop these removable or portable hard drives, they can become damaged. The other alternative to a hard drive is an SSD. They perform the exact same function, all right? But they use a different technology to get the job done. So a solid state drive, like the name suggests, is solid and has no moving parts, does not use a disk at all. Rather, it's more like a flash stick. If you've ever found one that broke or you've opened one up, you'll see that it has little chips on it, and the data is stored inside those chips. Because of this, it has a number of features. It is faster, it is more reliable and durable, it generally lasts longer as well. However, disadvantages are that because it is faster and new technology, it's more expensive per gigabyte. And they usually don't come with the same amount of storage. To give you an example, a hard drive might come with 1 terabyte of storage, which is 1,000 gigabytes, whereas a similarly priced SSD would only come with about 240 gigabytes of space. So, hybrid storage devices, using the SSD and the hard drive as well. I can speak from experience because I do the same thing with my desktop at home. I have an SSD, a 240 gig one, which is fast, much faster than a hard drive. And so I have my Microsoft Windows 10 operating system and all of my core applications and programs saved on the SSD. So the computer switches on fast, programs open up quickly. However, when it comes to other files which don't really need to be quick, which I might not use often, big files like game files, movie files, audio files, those things are saved on the hard drive because to open up those kind of files, I don't need a fast device, first of all, and secondly, I need the storage capacity more so with those. Flash disks, SD memory cards, CDs, DVDs, and Blu-ray drives. All right, you can see the images on the right-hand side which correlate with those. Most of you should be familiar with them, but have a read through if you're not. The motherboard, aptly named the motherboard. The motherboard is a big, fairly large printed circuit board. The main purpose of the motherboard is to allow all the other devices in the computer to connect to each other. So the motherboard has connectors where each of these other devices can slot in. So the hard drive, SSD, they slot into the motherboard. The CD-ROM drive slots into the motherboard. The CPU, the RAM, other things like SSDs, graphics cards and whatnot, also slot directly into the motherboard. Also, if you look at the back or the side of your computer and you see all of those ports are directly connected to the motherboard. You can see them at the top of the image on the screen. So audio devices like speakers, USB drives connect directly to the motherboard. Right, so we have input information, we have output, but in the middle of that, we need something to process the information. And so we have the CPU and the GPU. The CPU is the central processing unit, and it is intended to do most of the general processing inside the computer, whereas the GPU is specifically for graphical tasks, whether it be processing games or if you are rendering videos or high quality architectural drawings. You can use a GPU for that. And next we come to storage, very important. Not storage, memory. Now memory is your RAM most of the time, your random access memory. Now memory can also be called primary storage. So earlier when we looked at the hard drive, they called it secondary storage. When they refer to primary storage, they are often talking about memory, so RAM. Now, RAM also holds data and files, particularly the ones that you are currently using at the moment. The thing is, it holds that information temporarily and it is not permanent. So if your computer switches off, you lose electricity, whatever happens, whatever is stored in RAM or memory is wiped and you will not be able to recover it. That is why you have to save your work to the hard drive before you want to close the work or the document that you are currently working on. Now, why would we have RAM if it is volatile, if it does not store the data permanently? The main reason is speed. Unfortunately, the gap in performance between a hard drive or even an SSD and the CPU, which needs to process the information, is so vast that we need a middleman to try and broker the relationship between the two of them. So what essentially happens, if I can summarize it for you, when you open up a document, your computer goes and fetches all of the files and data it needs from the hard drive or the SSD or the CD or whatever storage, secondary storage medium, and it places it in RAM. It does this so that the CPU and the RAM can speak and transfer data to each other, ignoring the super slow secondary storage, therefore making the computer faster. When you're done editing the document, you press save. It then takes what's in RAM and it permanently stores it on the hard drive or the secondary storage. Our computers have a couple of ports at the back connected to the motherboard. The most well-known one is the USB. USB is usually for flash disks. We can connect our smartphones. And these days, most input and output devices like keyboards, mouses, things like that can be connected to the computer via USB. HDMI, as we mentioned, primarily for monitors, projectors, televisions, and even speakers because it can transfer video and audio at the same time. We have the 3.5 millimeter jack. These are for headphones. You find them at the end of your earphones, that little jack. And the last one there is our Ethernet. That is, or we call its proper name is an RJ45 jack, but it is where you plug in the network cable. And hopefully the last unit for today, comparing computers to mobile devices. So a mobile device performs many of the functions that a computer performs these days, like web browsing, running on the internet, playing games even, and even doing office work like Microsoft Word and Excel. The following table compares certain aspects, certain hardware aspects between a desktop and a smartphone. So we'll look at one of them. Let's look at the keyboard. A desktop obviously has a full-sized keyboard. A smartphone, on the other hand, has a small touchscreen alternative to a keyboard. You can use wireless Bluetooth keyboards, but that's rare. So we have the touchscreen alternative. Very interesting, they mention the world typing record on a full-sized keyboard is 216 words per minute. That is extremely quick, whereas the world record is 100 words per minute on a smartphone. And that's simply, to be honest, that's simply because it's smaller and you can't feel the keys underneath your fingers because there are no keys. It's just a touchscreen. So I've skipped a couple of tables. I'm not going to go through each of them individually. Just run through them once. Read through them. That should be enough. But let's look at another one over here. CPU, RAM, and GPU. All of them are built in. They're inside the computer. They're built in a smartphone. The only difference here is that with a desktop, you can open up the desktop and replace these parts. You can add new RAM, a new CPU, take the old one out. But with a smartphone, they're kind of, they're not meant to be replaced. And that is it from chapter 3, the basics of hardware. The next chapter, which we're going to look at for the June exams, is chapter 4, basic concepts of system software, but that is for the next video.